Okay, I think it's going. All right. Now let's get to work. All right. So starting off, this is test 21F, of course. What is the product of those two numbers? Type in it as you see it. 2.53. So 0.792. And let me pull up in the background the answer key. Just want to make sure I'm getting the right answers for y'all. Okay, and that is correct, of course. It's a pretty easy problem. 0.792. All right. Now, we calculate the product of these two numbers. Well, you're just multiplying it. And then alpha y equals to get your fraction, 8.22. You could also just multiply it and then divided all of that by 0.686, but I think that's easier to see. 7,250. 7,250. Okay, solve for positive z if that times z equals that time divided by z. Okay, so point, and we could also use some, yeah, actually, better yet, let's use some algebra. I wanna use some algebra. You could easily type that into your numeric solver, but just for practice, we might as well. So we have 0.383, 343, my bad. Z, and you want to add a little dash, so you know it's a z, not a 2, equals 0.137 divided by z, like I said, little dash. So, as you can tell here, if you divide each side by 0.343, then you'll be good. So then it'll end up down here. Then if you multiply each side by z, then you'll have 0.137 over 0.343, and then you'll have z squared, right? So take the square root of it. So let me show you what I'm doing. So we're dividing each side by 0.343. Okay, so that cancels out, right? So now you're left with 0.34, z equals point no, that's, never mind. Let me try that again. Times 0.343. So you have z now equal to 0.173, sorry, 137 over 0.343 times z, right? So now we're gonna have to isolate, which means we're gonna have to multiply each side by z, right? So now we're gonna have z squared. Z squared equals 0.173. It's 137. I keep on saying 173. I don't know why. 137 over 0.343. And then, of course, you can take the square root of both sides. So now you have isolated z, and that's all you have to do. Of course, that was the longer way to do it. I just wanted to do a little bit of a challenge, because I like it. But yeah, you could have also gotten the answer using the numeric solver. So that's honestly what I recommend. And let me show you actually how to do that. I mean, you already saw the first equation, so 0.343 times x. You could use z if you want, but x is just faster for me. That's what I normally use. 0.137 divided by x. So yeah, I would have honestly recommended to do that. And the reason also, whenever your guess is 0, if you try it, it won't calculate it. Because in this equation, x can't be 0, and if your guess is 0, it's going to throw an error, right? So it's divided by 0. So for my guess, I always like it being a number other than 0, just for those cases. And there you go. There's your answer. So moving on, we have two more problems. So this is an isosceles trapezoid area problem. It's the base times it's the base, the first base plus the second base divided by 2 multiplied by the height. That's the formula. Let me actually draw that. So b1 plus b2 and then multiplied by 0.5. You could also divide it by 2, same difference. 0.5, that's very bad drawing. Let me try that again. 0.5. Okay, and then multiplied by the height. And you'll just plug in as you see it. It doesn't matter what's base 1, base 2, either or. 5, 1. I'm just going to treat this as base 1, and then that's base 2 down there. And then of course you're going to multiply by the height. And you get your answer. See, pretty friendly. And then lastly, perimeter problem. It's a parallelogram. We're asked for the side length. We're given the perimeter. Well, since it's a parallelogram, you know that side equals that side, and that side equals that side. So what we can do with that knowledge is we could subtract the perimeter by this side length twice, minus 2.626 times 2. Right? Now that area, that's not the area, that side length, that perimeter, I guess, the partial perimeter, must be these two sides added together. And since they're identical, you just divide by 2, and you get the value of one of them. I didn't mean to do that twice, but yeah, 0.764. Oh, sorry, 7.64. Okay, moving on. Let me just clear that, cancel, and move on to the next problem. There we go. So daily, let me move this down here and mark up. 7 hours sleeping, 2 hours eating. So daily, Walt spends 7 hours sleeping, 2 hours eating, 8 hours working. His free time. So how many hours are there in a day? 24. You subtract all those added together, 17. I just did quick math, you know. You could also just done that in your head, you know. 7 hours. 7.00. Because you round to 3 sig figs. I'm going to try to write all. Oh, I did not have much control over my mouse, I guess. Not today. Donut costs that much, and it doesn't cost that much. What's the maximum number of donuts? What's cheaper to buy them individually than rather getting the dozen? So that's basically asking, in a sense, is how many single donuts could you buy to be in the threshold of $11.49? So we could calculate that by doing what 11 point. You'd have to do 1.19x, right? That's the number of donuts has to be less than or equal to 11.49. I guess it has to be cheaper. Never mind, it can't be equal, but yeah. So in this sense, we could kind of set it equal. So we could do 11.49 divided by, since like I said, 1.19x equal to 11.49. And like I said, x is the number of donuts you could buy, individual donuts you could buy. You could set that equal, and then whatever digit we get, whatever x is, we will have to round down, right? So then divide it. And if we get like an exact number like 12, we'll still have to go with 11 though, since it's asking us to be cheaper. It has to be less than. If it's at cheaper or the same value, then we could do that, but no. Okay, and like I said, you see you divide each side by 1.19, so you figure out what x is, and remember x is the number of donuts, so you'd put 9, which is the correct answer. Marathon race is that many miles and that many yards. Average time to run 1 mile. So, in this case, it's nice knowing how many yards are in a feet, of course, which is 3. So you're going to divide that, you're going to multiply it by 3. Right, that's how many feet it is, and then divide it by 5,280 to put it in miles. And then add that on top of the 26 miles, and that's how many miles he ran, right? And we're having to figure out the average time per mile. So, since there's that many miles, we're going to divide the total time by the number of miles. So it's going to be 2 hours, and we're asked in minutes. So we're going to multiply it by 60. So that's going to be 120. I could have just write it like that. 121 since it's 1 minute right there, plus 39 divided by 60. Because like I said, we're trying to keep it in minutes here. And we're going to divide all those minutes by the number of miles, and that's the time per mile. And then my mom's calling me, so let me pick up. Alright, I'm back. So now we have 19 and 20. So this problem is a one-step problem, which is why I won't be using the triangle program. Anyways, I want to show you how it's done without the program most of these times, you know. So I'm going to do it with 29 and 30 this time around. So we're asked for the angle, right? Relative to the angle, this is the opposite side. Opposite, that's the hypotenuse. And it's over h. Yeah, we're going to have over h. And remember, toa, right? So since it's it's going to be sine of theta is equal to that. And we're asking degrees, so we got to make sure we're in degree mode, which you can see right there. But since we don't know what the angle is, you could use a numeric solver, but there's a faster way, right? It's by using the inverse of sine. So then you just have theta, since the signs would cancel out, you'd have theta is equal to the inverse sine minus 1 of over h. So you could just type that in directly right here by doing second, and then sine, you see the little -1 sign, over h, 63.6, over 76.8. Just like that, you get 55.9. Okay, going on. And this one is it's a two-step problem, but it's fast. And what I mean by that is you could just use the Pythagorean theorem, then multiply it by this side by 2. So I'd first, just by using the formula, let's say this is x, right? Well, we're going to have, eventually, whenever we figure out the area, we're going to have 371 times x divided by 2, right? And I'm just going to write that down first, right? Then we can figure out what x is by using the Pythagorean theorem. The hypotenuse squared, the square root of the hypotenuse squared, minus this leg squared. And that will give us what that leg is. So now we know what x is. That right there, that's x. And we're multiplying it by 371, just like in the equation. And lastly, we have to divide it by 2. And that gets us our volume. So it's 97,000. Okay. Next page. Edit. Let me move this down here. All right. Looking good. Okay, so an old machine produces that many widgets per hour round the clock. So the current daily widget demand is that much. To meet demand, a second machine is purchased. So we're assuming that the new machine will be exactly meeting that 16,000 threshold, right? So first of all, we have to figure out how many the old machine creates per day, right? So 235 per hour. We're going to multiply that by 24. So that's the daily production of the old machine. So we're going to subtract that from the total to get the output of the new machine. And we're asking widgets per hour, so that's the number of widgets that they make per day. So we'll just have to divide it by 24. Because we're also assuming it works around the clock, just like the previous one. And we get it to be 432, which is correct. 432. Sorry for the bad handwriting. I don't know if I can get better with that eventually, but we'll see. The product of two consecutive integers is that. What is the smaller number? Again, I've solved this before in a previous video. You'll just take the square root of that number. I didn't mean to do that twice. 108,570. Bang. So it's right in between 329 and 330. So those are your two numbers since they're consecutive. And you're asked for the small number, which is 329. That's pretty easy. 329. Okay, then Lake Sevan is a high elevation lake in Armenia with a surface that much above sea level. So if drainage pipe were extended from the lake down to the sea level, what would the exit pressure be? Whew, I'm not so good with these problems, but let me see. I'm not too familiar with having to do PSI. This is new to me. Well, I'll come back to that. We'll see if I have time. I might give it like 10 minutes to see if I can figure it out later. But let's do 29 and 30 since these are the easy ones. So, of course, you could use my program for them, but this time I want to figure it out without the program, just to challenge myself. So square pyramid, you have to know the formula for it. And the formula is the base times the height. This is volume, of course. Base times height divided by 3. And the base, since it's a square, is simply 818 squared. And then, of course, times the height, 719, divided by 3. See? It's really, okay, that was a terrible 3. You see, it's really not too bad. You could honestly, there might be some cases you can solve these problems faster than using the program. So, it's helpful whenever, like, for this problem, for the cone problem, it's probably faster using the program. But that's just my opinion. Depends on how you're wired, I guess. But you get 1.60 times 10 to the 8th. And also, I just counted those zeros really quickly, but if you don't want to have to do that, if you don't want to mess up, you can put in scientific notation, look at the first 3, then you see the little 8 to the 8, that means it's times 10 to the 8th. So, little trick. It only takes you a second. 1.60 times 10 to the 8th. There we go. And finally on this page, we have a cone problem. This time we're given the volume, which is a little bit more difficult. So we're going to have to use the numeric solver for this. Just because I feel like that'd be faster than using geometry. We already used a bit of geometry on the first page or whatever. Maybe it was the second one. We're going to set the volume equal to the radius. And the radius is we're going to call the diameter x, right? We're going to have x divided by 2, right? So that's the radius squared times pi times the height divided by 3. So yeah, in this case, it's pretty easy to isolate for it. The program actually isolates it for you. It has the whole. I used geometry, not geometry. I used algebra to isolate for each individual like I guess yeah variable, and it would solve it for you. So in this case, you could multiply each side by 3, divide by that, take the square root, and multiply everything by 2, and then you get your answer. But I feel like overall, numeric solver will just get it to you a lot faster. And just like that, 0.609. And like I said, 28. I don't think it's that hard of a problem. I just don't want to have to do it right now. Okay. Okay, I forgot to write down my answers to the last page, so I'm writing that down really quickly. Turning it. Here we go. So it's 432, 329. And then the PSI one, I couldn't figure it out at the moment, but yeah, the geometry ones I've already done. Cancel that. Okay, so we'll come back to that. Alright, so the dwarf planet is that many units from the sun. And AU is the average distance from the sun to Earth, that many miles. What's the shortest time to travel from Earth to Haumea to vehicle speed where 10% of the speed of light? So, it gives us the speed of light, so we're going to use that. It's a little bit off, of course, it's not exact, but we're just going to assume that that's right on the dime. We're going to use that because if we use the actual speed of light, that could cause a little bit of an error. Okay. So, since it's that many from the sun, right, and an AU is the average distance from sun to Earth, what we can do here is we're going to assume, let me draw a little diagram to help you understand. Oh, sorry, let me close my door. Alright, here we go. Let me draw a diagram for you. So, we know that the distance from the sun to the planet is going to stay roughly consistent, right? So this is the sun right here. And let's say this is the planet all the way out here, right? This is not going to be to scale. This distance right here is 34.8 AU, right? Which we're going to have to convert it to miles, which it gives us the distance right here. That many million miles. We'll use it. We'll convert it. All right, but yeah, it's that many AU, right? Well, Earth could be anywhere around the sun, right? Earth is very close to the sun on this diagram, right? But if we're asked for the closest distance from Earth to the planet, it will be in between, right in between the sun and the planet, right? So it's going to be right here. So, and also this little line's supposed to go all the way to the sun. Let's say the Earth is right here then, right? Well, this distance right here is just the distance from the Earth to the sun, right? Which is an AU. So the distance from the Earth to this planet, in this case, would be 33.8 AU. 33.8 AU. Just like that. Okay. So 33.8 AU is going to be, and multiplied by 930 million, not 930, just 93 million miles. So multiplied by 93 and then 10 to the power of 6. And that's how many miles it is, right? Now we're going to have to divide it by the speed of I guess the vehicle speed, which is going to be 10% of this, which is just 18,600. And oh yeah, I forgot to do the division sign. And insert division. There we go. So that's how many seconds it is, and we're asked in hours. Oh, no, we were asked in days, sorry. I was looking at the wrong problem. I just saw a time, and I thought immediately that's what it was. So, divided by 3600 to put in hours, then divided by 24 to put in days. And we get 1.95. And I better switch my answer key. And 1.96 rounded. Yep, that's right. 1.96. Let me write that down over here. 1.96. Well, in this next problem, I actually have a formula, I have a program for, but we're gonna use the regular one. So we won't use the program for this one. So you have this initial value, which is 2,500, and it's doubling every 5 years, right? So it's the same formula as a half-life, except instead of 0.5, it's 2. And 3.5 years have passed, and the double life is 5 years. So that's the formula, and you get 4,061.26, which is correct. Now, 38, I'm not going to lie, I am not familiar with 38. The sinuously, I still don't know what that means. I haven't learned it, so I will not be able to help with that. And so there's 2 problems so far I haven't been able to solve, but maybe that other one I can come back to, with a little bit of help. But this one I'll definitely have to learn a little bit later. Maybe even the second 9 weeks. I'm sure I could get a lesson from it from my teacher. Okay, so this problem 39. I normally immediately use my the triangle program for it, but in this case it's pretty friendly without it actually. You can make this diagram right here. So we know what this angle must be because it's split basically into 3 equal segments, right? We're basically splitting the circle into 3 equal segments, each corresponding with their own section of the triangle. So this right here is 120. 120 degrees, right? And we know that has to make a right triangle, right? Because it is a tangent point. It's a tangent line to the circle. So if we split it in 2 like that, guess what we get? We get a 30, 60, 90. 30, 60, 90. And we know what R is, and we're asked for the side length. So this right here is half the side length, right? Actually, let me think about that. Is it? Let me check my work right here. 3 to 3, yep. Okay, it is. Yeah. It is. My bad. I don't know why. I guess a bad diagram, but yes, this right here is half the total side length. So we know what this S is. Let's call it R, right? Well, using this diagram, that's going to be R squared root of 3, and then the hypotenuse is just 2R, right? Well, we don't care about the 2R. We need the R squared root of 3, right? So 8.86 square root of 3, bang. So that's that length right there, right? Well, now we're going to have to multiply it by 2 to get the total length. And we get 30.7, which is correct. Most of the time, I can't really do these triangle programs. Not triangle programs, the triangle problems without the program. But in that case, I can. Okay, now in this case we're asked for what AB is, and I'm not gonna lie, in this scenario I will just immediately use the triangle program because I honestly haven't really learned how to do it with otherwise. I'm sure you might be able to use altitudes. I think that's how you're supposed to solve it, but I haven't really learned it. So what I have learned is how to use this program. So I'm sure you can watch some other videos that could explain the math behind this, and you can learn it yourself. But I'm not going to do that right now. So what we're doing, right? We're going to run this program 2 times. We have to find an angle because we're asked what AB is. Well, we could, if we figure out this angle right here, for example, right, which is right here, 30.494, then we could figure out what the side length is by using side angle side. If we figure out what that angle is, side angle side. So it's stored under D, right? So triangle, we'll go right back in, side angle side, bang, 49.6, and the angle is D, it's under variable D, then 39.9. And you get 25.3, which is correct. Okay, so I forgot to write down the other answers, but you saw it on my calculator, so I think that's still good enough. Of course, on an actual test, you have to write down the answers. You can't just say, "Oh, it was on my calculator," you know. But I don't really like drawing on here personally. I much prefer pencil and pen. But my handwriting's bad either way, so it doesn't really matter. It's just a lot faster with pencil and pen. Okay, so the cost of the rubber figure scales with its volume. It doesn't actually, normally this problem doesn't even tell us that. So they were very nice to already tell us the scaling. So it makes sense because, if you're increasing the volume of something, the cost will scale with it because the weight scales with volume, right? Like the more volume you take up, the more weight you take up. It's linear for the most part, right? But yeah, but for example, if all your dimensions are increasing by the same amount, like if you're building or like something's increasing, like a wall, or I don't know, just some scenario where all three dimensions are increasing, then you could say that a side length, right? While the side length increases, the volume increases at a different level. It's not increasing linearly; it's increasing cubically. That's kind of weird, but I think you can understand what I'm trying to say. Okay, but as I was saying, we already given that it's scaling with the volume, right? We're given the height. So, uh, and like I said before, with the rubber duckies, for example, it's not just like you're not only increasing the height, right? Whenever you're increasing the volume, you're also increasing the width and the length of it, okay? Because you wouldn't want to have a really stretched out rubber ducky, you know? You want to have a rubber ducky that's huge, right? Someone might want a huge rubber ducky, but they want a rubber ducky that scales, in all dimensions, so they're not super stretched out. So this scale is we're gonna have to cube it to put it in the same with the cost, right? Because we're gonna have to put it the same as volume. So we're gonna have 5 inches cubed, which now that's gonna be in the same dimension as volume, which is the linear to the cost. 3.98. If I could put the 8, there we go. And then we're asked for the height of another one, which we don't know, so we're gonna have x squared, or x cubed, my mistake. We're gonna put that over 39.99. Just like that. Like I said, well, in this case, x is above, so I think we can have 0. There it goes, yep. So it's 10.4, which is correct. Like I said, normally these problems don't give us the ratio between stuff, but you should be able to figure that if the volume of something increases, the cost will increase linearly with it. I guess sometimes there's like Like for manufacturing, sometimes the cost is there's other factors other than just the material, like the printing or whatever, but this is this isn't accounting for that. Okay. So 47, we're given this is just a stat problem. So you load up stat, edit, you'll plug in the data points as you see it. And again, we're only given one dimension, right? We're only given the feet. So it doesn't give us that the feet scales differently than the volume, like the feet long, my bad. So think of it, right? When a line is growing, it's not just being stretched, right? It's increasing in all dimensions. So we're gonna have to put the feet, right, which is just a one dimension, it's just a line. We're gonna have to put that in the same dimension as the pounds. So there's two ways you could do it. One is by cubing this 7.2 feet. You're cubing all the feet to put in volume in a sense, and volume, like I said, scales linearly with weight and cost. Or you could take the cube root of the weight to put it in one dimension. I personally prefer taking the cube. That just makes the most sense to me, but like I said, either way will work as long as you stay consistent. So take the cube of all of this, and then we have a 40. Also, oh shoot, look at that. It threw a curveball. 40 inches. So you're going to have to do parentheses 40. You're going to have to do the conversion first, and then you're going to cube it. There we go. See, that was a bit of a curveball. That almost caught me. Okay, then put all the pounds. 180, and then 52. Set, edit, calc. I just prefer using linear regression. I guess, in a way, you could still type in the points as you see it. You just have to use you'd have to use a cubic graph or whatever. But no, that wouldn't work because a cubic graph would eventually go down. It has a curve. So yeah, I think converting it to linear that's how I do it every single time with this problem. So that's what I recommend. Okay, so I have to estimate the weight of an 18-inch long house cat. So we're gonna put y1. We're gonna have to plug in 18, and we're gonna have to convert it to feet because that's what all the other things are in. And I think I could just cube it on the outside, and it's gonna do the parentheses, and then it'll treat it as x. Okay, 3. No, that's definitely not right. Let me fix that. I guess I should have probably done this to begin with. Okay, I'm gonna take the cube of that. There we go. Okay, yep, that seems correct. See, I guess never mind. For some reason, it treats that as x first, and then it cubes it. That's really weird. Interesting. You'd think the exponent would go first in the order of operations, but nope. And that's why, even though I thought that was right, you could immediately tell that was the wrong answer. Sometimes it's good just to check, do a mental note. Does this answer, look close to what it should be? Because obviously, a really small 18-inch house cat won't be weighing 3,815 pounds. That would be one fat cat. Okay. So, 48. For a negative value of w, does negative 1, less than negative 1, does all that equal whatever? This is just going to be numeric solver. 48 is always a numeric solver problem. That's why it's really handy having a TI calculator. Okay. Plus 100. And you're going to set it equal to 2 divided by x squared. And here we are. You see it's less than negative 1, so that's true. It meets that criteria. And it's negative 4.57. Okay. Now we have we have two geometry problems. I think I could do number 50 if I remember correctly, but I might need to. Let me actually check. I think I have it supported in my program. Number 5, rectangular prism, 3 face diagonals. I do, but I do think it's a little bit weird. And what I mean by that, we're only asked for volume, so I could plug it in whichever way I like. I'm pretty sure it doesn't really matter. Actually, I will treat it as I should. Yeah, I'm gonna call this the length, and oh, no, I already messed up. Let me do that again. I think it is useful to have some consistency. Just easier to look at it. Okay, geompig, rectangular prism again, and three face diagonals. So length and width, that's AB. So yeah, I was doing it right. Never mind. Yeah, 64.4. Now we have length times length and height, which is AC, 61.7. So it might throw an error. I haven't really worked with it that much, but let's see. Take the square root. Yeah. So what I mean by that, what I did here, I squared all these side lengths because initially they're in negatives, right? But we can't deal with negatives because that's no bueno, right? But it does work correctly. So the answer is 8,790. It uses a matrix. So let me remember if I can do that correctly. 8,790, which is again your correct answer. But and I'll come back to 49. 49 is pretty easy, but I just wanted to use a program for this because I don't think I can use the program over here. All right. Okay, so if I remember correctly, at least we could actually check the program, like I said, using matrices. So we could just look at what they did by opening up matrix A. So this is we have side one. Oh yeah, you see, it's the Pythagorean theorem, right? And we can't do like so we're gonna have let me try to show you what this is doing, right? So it's AB. So the distance from A to B, it's going across these two dimensions, right? So it's going to be this right there. That squared AB, the distance squared, is equal to this plus that squared, right? So over here, I squared the distance, right? And this is why all the dimensions are. You have to take the square root of it to figure out the actual value, right? Because I don't know how to support it directly in one matrix. So if you need to figure out what like the length is of something, right, of some side, you're gonna have to figure out the square root. You're gonna have to take the square root of it after the program gives it to you. But yeah, this is basically all you do. Then you're gonna take the RREF of it, matrix RREF. I don't really know what it stands for. I'm just used to doing it. And you see, it will give you all the values. That's exactly what you saw in the program, right? Now, again, like I said, I'm pretty sure you have to take the square root of all these values. 0.52, the square root of 392.84, and then finally the square root of 52.37. And then you will multiply all these, and I think you'll wind up with the right answer. If not, I can check what the program's doing. Yep, you see, it's not that bad. It's just you have to use a matrix for it. Okay, but that's what the program does for you. You see, it's very handy. It's saves you a lot of time. But yeah, you will have to take the program gives it to you. I'm not trying to touch that program. Whenever I made that program, I knew what I was doing, but it's been a while, so I don't want to touch it. If it works, don't fix it. If it ain't broke, don't fix it. That's the saying. All right, cube volume minus cone volume equals that. So that 500 is the volume of all the stuff on the inside without the cone hole, right? The cone cavity. So if you add the cone volume, it will be the total cube volume, right? I mean, there's multiple ways that you could solve for it, but I'm just going to keep the formula they gave us. This is a very easy problem if you know how to use the equation solver, the numeric solver, and you know the formulas for all this stuff, right? Well, we can tell the cone fits in perfectly, right? So the diameter is S. It's the side length. We're going to call it the side length S. And this right here, that's all S as well. So the radius, which we're going to put over here, is going to be S. I'm going to put an X. I'm going to keep it S. I want to stay consistent for y'all. On a regular test, I'm going to do it, but just for y'all, I'll do it. The radius would be S divided by 2. and we're going to square it because we're getting the volume. We're going to multiply it by pi. Now we have the base. We're going to multiply by the height, which is also s. And we're going to divide that all by 3. Oh, I should have put that second. My bad. Yes, minus all that junk. And we're going to have x. I should have put the cube volume first. But yeah, the cube volume is simply x. Sorry, I did switch up to x. My bad. I just said I was going to stay with s. Oh yeah, s, and we're going to cube it. That's the initial cube volume. We're subtracting the cone volume, and that's going to give us our remainder. Like I said, the area around the cube that wasn't taken out by the cone. So you solve for it, and you get 8.78, which is correct. 2 more pages. What are we looking like on time? I don't know. 40.56. I'm also trying a new recording thing. I will check on the quality after. If it's not a good quality, I'll go back to what I did before, but I'm not trying to go through all this again, personally. This has already taken a bit of time, so. Alright, well, these problems look pretty friendly. We got a hashed area problem for that, and we got just a triangle one right there. Very easy, very friendly for us and what we have. Alright, markup. Calculate the area underneath the curve. So, of course, it says radians. Even if it doesn't say radians, assume it is. You know, these problems are almost always in radians. Okay, that's just my advice for you. Radian. And you're going to have the graph of the curve 5 sine x times pi divided by 10. You're going to add 8 to it. So that's the graph. Now we're having to find the area under the curve of all of that between 0 and 10. So if I'm correct, you could just do 0 to 10. That's the lower bound, that's the upper bound. Y1, and then d of x. Let me check on my answer key. I just want to make sure I'm doing it right, because that seems too easy. But yeah, that's correct. 112. My pen isn't working that well. All right. Shoot, I did not mean to draw that. 57. That is a calculus problem. Closest approach. I do not know how to do that. So that's my third problem I will be skipping. But if you only skip 3 problems on a test and you got all the other ones right, you did pretty well. That's state level. So, you know, you don't really have to worry about, like I said, most of the time 57, pretty difficult. Even if you're good at calculus and you're familiar with it, it still might not be worth it to even try solving it during the test. After the test, you have all the time in the world, try it, you know. But I haven't taken calculus yet, so I will not be attempting it. But one day, I'll definitely know how to do these, and I will be explaining it to you. So, but that day is not today. All right. So, again, we have a matrix problem for 58. It's always a matrix problem. Sometimes they vary in difficulty. This one's pretty easy, as long as you know what T23 is. So, what that means is, I think I already said it before on another video. Remember, I'll show you after I plug this first one in. It's going to take me a second though, because I have to look back, and then I have to look over here, look back, and it's a little bit slow. But I'm sure you'll be faster plugging it on your own, you know. 7 to 3, and finally 9. And if you forget what that means, like what the 2 and 3 is, it's just the order and you see it, right? You have row and then column, right? Row and then column. So that right there is row 2, column 3, right? That's just my little hint of remembering that. And minus 12. That's just the form they put us in. They put us in. They put it in. I don't think I'm a matrix. Or at least like I'm not that right there. Alright, 6, negative 12, 6 again, and then 10. Like I said, it's row 2, column 3, 108. 108. I'll definitely try to go back. I forgot the third problem I skipped? Let me see if I can find it here. So this was the third problem I skipped. I skipped oh yeah, the sinuously or whatever. I don't even know how to say it. And then the PSI. PSI, I might try looking it up and just see if I can find an explanation because I don't know how to start that, but we'll see. I haven't really done this before. I'm sure they're easy, you know. They're just a formula. I mean, it's only 28, you know. Most of the time, the first 4 pages aren't too difficult. Most of the time. All right. So for this problem, we're going to have to do a couple things. I figure out this intercept. That's a terrible line. We have to figure out this intercept, and then we just have to take we have to figure out the area in between these 2 points, right? How you can do that? Oh, shoot, what did I do? No, I messed up my calculator. There we go. It's fixed. I'm gonna take a second to drink some water. There we go. That's a lot better. Okay, program. No, we don't need a program. What am I doing? 5 cosine, not sine, cosine, and 8x. There we go. And make sure you're in radians, which we are. And we're going to just graph it. Actually, you know, better yet, it'll take a second because our calculator's pretty slow. I just recommend doing this, setting the graph to 0, and then just trying to figure out, just putting maybe like 1, or yeah, put it at 1. And there we go. See 0.98, and it's stored under x. You have to remember that. Math 9, the balancer from 0 to x, which is that intercept, not y1, x. I did not mean to do that. And then y1, and then d of x. That should get us our right answer. 0.625. That is correct. 0.625. Then we have a scaling problem, scaling triangle problem. It's my mistake. We're asked for this angle right here. There's a couple ways you could do it, but I'm going to start off just by getting all the angles of the triangle. Oh no, I didn't mean to do that. Yep, there we go. 21.2. So that's that side right there. Then 14.2, and then 17.2. All in I guess not really decreasing order. Okay, so that angle right there is 84 point whatever. I'm just gonna say that's angle D, right? And then that angle is E. And you can see the values right here on the screen. You know, I'm just not trying to say that again. I'm not trying to write that all down. On a regular test, I probably would, but I think we're only gonna run the program one more time. So now that we get that, now what do we do from here? We have, alright, so we have side, that angle is being split, and we have another angle. So angle, side, and is that we're given, oh, I forgot about that. Yeah, we're given that side length. So once we get F, I think is that enough? Or do we need something else? No, yeah, that's enough. Yeah, it's side, side angle then. Side, side, angle. I didn't see that we had AB solved for already. 12.1. That's why you always gotta look outside of the problem, you know, in a literal way. So we gotta remember that's angle F right there, but we'll exit it if I can actually. There we go. So it's side, side angle. First side 12.1, and then 14.2, and then angle F. And then it'll solve for all these. We're looking for angle 2, since that's side 2, the corresponding angle would be angle 2. So that's definitely not 108. So sometimes with these triangle problems, they will have 2 sets of answers. So sometimes you have to scroll all the way down, it will have an or, right? And since like I said, since that answer wasn't accurate, you know, since definitely that angle isn't 100 or whatever, you just go on to the second set of answers, and there you go, 71.4. So 71.4. And you could go into the nitty-gritty in it and why it gives you sometimes two sets of answers, but honestly, I think I knew a while ago whenever I was looking at the code, but I do not remember. So I think it just has to do with what all you're given. You know, like this angle corresponds to that side, so you don't know anything about this side length right here. You know, you don't have the side length or the angle to it, so it has two sets. You know, you have two possible answers, but you probably know. You might know it better than I do. Okay, but you see, this second to last page was very friendly, except for 57. But like I said, we're skipping it for time. And also just because I don't think I could do it with all the time in the world right now. Uh, here we go. All right. So 61 looks kind of scary. Um, but let me get back to that. I forgot to write that answer. 108 for the matrix problem. There we go. Everything else is already got. Okay, yep. 61 is definitely going to be the scariest one on this page. The others I've got already. So, and 62 and 63 are just programs. So, 61, two 5 feet tall posts are separated by that many feet in between. A string is tied to the top of each and is pulled tout. I don't know what tout means. Let me look up what the definition of tout is. Alright. Yeah, it's just stretched. Okay. It's just stretched. Alright. One post is then moved 6 inches towards the other. Assuming the string forms a circular arc, what is the height of the string midpoint above the floor? Oh, interesting. So, it's basically dropping, you know, it's loose, and it's asking us for the height. So it's basically asking us for the radius. Huh, interesting. I mean, that seems... I should make a diagram for this. Nope, I did not mean to do that. Let me crop that all the way there. Let me try to make a diagram. Oh, interesting. So they're moved together after you already made the circle. So it's going to be looser, or whatever you want to call it. It's not going to be a semicircle since it's moved. Like if, for example, you know, let's say like you have it's perfectly tied, right? It's perfectly tied to each other. Then that's the pole, that's the pole. If it's perfectly tied, then it's gonna be like that. But if you move it together, like this, or actually let me delete that. If you move it together, like right next to each other, that same length will flop down, you know, towards the ground. So it's still making a circular arc, and you know that's the reason it's doing that is because of it's because it was moved together. So 5 feet tall, and it's to the top of each. And I'm just gonna say that those are 5 feet. They're a little bit too close in terms of the diagram, but that's okay. 5 feet, 5 feet, and this distance is going to be what? Well, it's not 8 feet. It's now 7.5 feet. Never mind. Maybe my diagram isn't that bad. Okay, and this length is going to be 8. So, and we're having to find let me move that a little bit. We're having to find this high right here. 8. Well, this is going to be very interesting. I don't know if you could, what would the radius be of that? Because that's part of the circumference, right? Could you say that there are exactly 4? I don't think so, but what else could you do? So you know, it just made it was just making a perfect line, and then it folded a little bit because it was moved a little bit closer. Hmm. I'll think on that. But first, I want to get these other problems done since they're easier. 62 and 63, just program. Yeah. Also, in this scenario, I'd come back to 61 if I had more time. I would do all these first if you could. 61 is probably the most difficult on this page because, like I said, I've already gotten the others, but I never looked at this one. Okay, it's the exponent problem. 8.8 times 10 to the 26 meters, and 307 is the power. And it gives you the answer. Let me write that down. 9.04 times 10 to the 8271. Other than the program, there is an easy way to do these problems, these overflow problems, but I don't have it memorized. I don't have it memorized because I have the program, you know? I mean, why would I memorize it if the program already does it for me? That's my whole thing. And, I mean, I get it. Sometimes you have to memorize it if, like, for example, the geometry, you know? I still have all the formulas memorized, even though I made the geomfig program. Just because it does most of them for me, it doesn't do all of them for me, so I still have to do some critical thinking. So, no matter how many programs you have, you still have to be somewhat smart, you know, to score well. Because there's enough diversity between the tests. And your calculator is only so much storage. But, okay, that's a whole bunch of yapping. Let me go back. I want to make sure I pull my answer key. So I'm going to need that for 61. Alright. So, what is this number? Okay, yep, we already got that one. Yep, 9.04, whatever. Now we're on 63. It's just a trajectory problem. Program, it's on Earth. You're given, let me see. So it's running down the field at that speed. At the same time, it throws the ball that fast. So the catch is completed. Wait, does it say the time? In a football game, the fullback next to the quarterback starts. Oh, okay. At the same time. Oh, I see what it's saying. Oh, that might not be. I don't know if we can use the program for that because it doesn't give us the time for it. So technically, these two are running at the same time. The 30 feet per second is running on the floor on the ground, but the ball is running in a parabola in a sense, right? So you'd have to figure out like the intercept. There's so many variables. It could go all the way up. It could go pretty much flat. Like, interesting. Yeah, I don't think the program can help you with that, and I don't know the formula for traject or whatever. We could just guess, but horizontal distance. Yeah, let's just say the horizontal distance. The velocity is going to be 52 feet per second. Let's say the horizontal distance is, let's say it's 45. So it was up in the air for it was thrown for 1.5 seconds. Initial height is 0. And what does it do? Well, apparently that's one of the answers, but obviously that's not it. Uh, that is not the right answer. And of course, time is off too. The time is off. So if it was thrown that far, it would take 3 seconds to do that. So, oh shoot, it's just using the next program. Oh yeah, honestly, 63, we can't do that either. Not with the program. And like I said, I don't know how to solve it without it. So that's the fourth problem I couldn't solve, and hopefully I could solve 61, but we'll see. Maybe I skipped 5 of them this test. That's not a good sign. I thought I was good at this. All right, going on. Uh, so for this problem, we know that it's a parallelogram, and that they have this area. This hatched area is the same as the parallelogram. And we know what the radius is. So, and the radius is the same as that right there, right? So the volume, not the volume, the area of a parallelogram is the height times the base, right? Which we could figure that out. Let me actually think about this. We could figure that out by using the radius is the hypotenuse in this right triangle. What else? Hmm, hmm, hmm. Well, you're going to have to set. We might as well start with angles. So that right there, that was a very bad angle. That right there, let's call that theta. And then this angle down here will be 360 minus theta. Okay, So we're trying to simplify that there. So theta over 360 times r squared times pi. That right there is the simplest version of the circle, the sector's area, right? We're going to have to set that equal to 65. I forgot that it gave us the area, but we can't quite. Can we? No, yeah, we do, because we know what r is. Yeah, we can figure out that angle. Never mind. Yeah, this is actually super easy. I forgot that it gave us the area down there. I just thought it only gave us this part, but it gives us all of that. I didn't see that at the end. That's why you got to read the whole problem. All right. So yeah, that's very easy. So you just have the r 5.65 squared times pi. That's not squared. That's the inverse. I'm not trying to do that. All right, and then theta. There's probably an easier way to do that, but yeah, x over 360 is equal to, and we're in degree mode. I don't, yeah, it does matter in this scenario. Actually, no, it doesn't. What am I saying? Okay, so we know what x is. X is the angle. So 300 theta, we know, is 233. And now we can figure out what that angle is down there by doing 360 minus theta, which is stored under x. So that right there is 126.67 degrees. But we're going to subtract 90 because that angle right there is 90 degrees. So now we know that that angle right there is 36.67 degrees. We could figure out what the height is by using SOHCAHTOA, right? And this is the angle that we know. That's the opposite. No, that's not the opposite. That's the adjacent. And that's the hypotenuse right there. So it's a over h, cosine. The cosine of theta, which we know, is equal to a over h. And we don't know what a is, but we know what h is. So instead of a over h, we can just have a, then multiply each side by h to put h out front over here. So we can plug that into our calculator. And the hypotenuse is r, which is 5.65, times the cosine of 360 minus x minus 90. Took a while, but yep, there we go. So now I know what a is, 4.53. And using this formula again, we could do 65 divided by the height, and that gets us our answer of 14.3. That's the base. All right, a little bit long of a problem, but not too bad. 65 square and segment problem. R equals what? And then hatchet area equals that. All right, well, we know that we could figure out what these angles are going to be. Actually, wait, first let me think. I think, yeah, we will have to figure that out. We'll have to figure out what all these angles are going to be, if I can actually draw a good line here. So, first let's see what, we have to figure out what this triangle is, right? And this right here, that's S, and we know it's a square, so we got to put all these in the same units. We got to put them in alike variables. So we got to figure out what. Let's call this S. We'll just keep S a nice number, but we got to figure out what this hypotenuse is in a sense in terms of S, and we could use that by using just the triangle program. Actually, no, we don't even have to. Let's say in this scenario we can make up numbers, right? Let's say the side length is 1, and since that's a midpoint, that's 0.5, right? And then what would the hypotenuse be then? It's the square root of 0.5 squared. That's just 0.25 plus 1. And so the hypotenuse would be that much, right? So this right here, that hypotenuse is 1.118s. That's the ratio. Since the side length was just 1, if you divide it by 1 to put it in the scale factor, it's still the same thing, right? So that's the scale factor between S. Sorry, my mic keeps on turning off. That's the scale factor from S, the side length, to the hypotenuse right there. So, as I said before, we could just make up a number to figure out the angle, right? You could also make another right triangle and use whatever. But in this scenario, I'm just gonna use this. So let's call S1 again. We're gonna have 1.118, and then 1.118 again, and then we're gonna have 1, and that's gonna give us our angles. 53. That's good. 53.13. Oh yeah, let's call it 132. 53.132. That's angle F. Let's remember that. All right, angle F. Now we have to remember the height right here is S. Oh, that's a very bad thing, but that's a very bad drawing just because I didn't want to have to mess up F. I'll put that out there. F degrees. Let's draw it down here again. Let's ignore the S. That's fine. But yes, you know what I'm saying. That's a 90-degree angle. That's splitting it in half. Uh, so we could figure out what this area is right here. It's actually it would be half the area of it would be half the area of the square. So it'd be S squared divided by 2. The reason I know that is because since the base is S and the height is S, and it's a triangle, it's the base times height, S squared divided by 2. So I wasn't even thinking about that. That's pretty cool. All right, that's not really important. So we're going to have. Oh, and shoot, I forgot. We have to have R, and R is 1.118s. So yeah, we can solve for what all this is now. We're gonna have to do F degrees. Actually, shoot, no, is it still saved under F? I don't remember. Let's check. Yeah, it is. I just got it. So yeah, we're good. So yes, F. F. That's the only worry about me using variables. Sometimes they get replaced and it'll throw you off. F uh, over 360 multiplied by R X. We'll just have it be. Actually, it's asking us for R, so I'm gonna have R be X, and then whenever I put in the side length, it'll just be X divided by 1.118. That's the same scale factor, so we'll be fine. Yes, divided by multiplied by X squared times pi. Now that gives us the area of this whole thing right here, this whole chunk of pi, right? Now we're gonna have to subtract what the triangle is, and the triangle is X or S times S divided by 2. But as I said, we can't just use S, or in this equation, I'm just using X. We can't use X again because I decided that I'm going to use R, right? So we're going to have to do X divided by 1.118. Remember, I'm just trying to use R instead of the side length of the cube, not the cube, the square. Squared, and then we're going to divide that by 2. And hatched area is 0.482. And we get, all right, I forgot I used F up there. Why did I use F? Oh, wait, shoot, we can't even use variables in here without, it's thinking that we're trying to solve for it. That's my mistake. 0.132. All right, never mind. That'll give us our answer. And change it to something other than 0. And 2.75 is your correct answer. So, there you are.